Okay, so yesterday we did start on 9.1 and we just learned how to graph. We didn't get too in depth with them. But now we need to talk about some more details. So one thing we need to talk about is how do I decide what direction it's facing? So going in, when I want to look at my graph, so I know that this is a lot of words, so let's break it down together. So notice that it is a quadratic. This only works for quadratics. There's different rules and things that go with lines. So when a is a number bigger than 0, so remember a is that number in front of x. It's just the number, it is not x. When a is bigger than 0, that means I'm going to have a minimum, because that means I'm going to be facing upward when a is positive, like this first graph down here. Okay, so when a is negative, I'll have a maximum value, and that's because I am facing down. So those max and mins are going to make a decision for us when it comes to domain and range, as we've talked about in the past. So we want to make sure that we know, is a positive or negative, because that's going to help us out. So getting started, if we want to consider f of x is equal to negative x squared minus 2x minus 2. The first thing I want us to do is go through and decide what are my a, my b, and my c values. So take a moment and go and do that. Okay, so my a is -1, my b is -2, and my c is also -2 in this case. So remember, we just talked about how it's all going to depend on what a is. So in this case, a is negative. So do you remember from the previous slide what direction it should face? Take a moment and answer that question for me. Okay, so that answer should be because it's negative, it's going to open downward. Okay, so that open downward's a big deal, and it also tells me I have a maximum value. That max will happen at the x value of our vertex. Okay, it'll happen there, and my y value will be what is its actual value. So let's go and see how we can work that out. So same equation. Okay. Let's go back to the other side. There we go. So same equation. Let's actually state what the max and min is. So the actual max value will be the y-coordinate of our vertex. So to find the y-coordinate, first I have to go and find my x-coordinate. So we don't want to forget the first value. How do I find the x-coordinate? I use that using my axis of symmetry formula. So my x will be negative b divided by 2a. Well, we already found a, b, and c, so that would be negative times a -2 over 2 times -1. So go ahead and simplify that out for me, which gives us, 2 of those can cancel out, but that'll give me -2 over 2, which gives me -1. Okay, so that's the x value, but I want the y coordinate. So that's one thing we did that in our table yesterday, but we just didn't do it outside of the table. So to find the y value, what we will do is I will take f of that vertex value I just found over here. And remember, when I put that number in right beside it, that means I'm going to use function notation and I am going to plug in. So that means I'm going to have negative of my -1 squared minus 2 times -1 minus 2. So now we're just going to go through and work that out and find out what my value is. And so in this case, -1 squared is 1. -2 times -1 is +2. And then at the end I have that -2. So we'll go through and I'll get -1 plus 0. So I get -1. So my point is that -1 I found from my formula, and then the y value I just found. And so that is my vertex. So the max value is -1, and it happens at the x equals 1. So I'll write that up same way, just a different way to let you view it. So we'll take the original function, and I'll plug in that -1, and then I will evaluate it, and I get -1. So the maximum value is -1 because that's the y value that goes with my vertex. Okay, you'll have a few problems that it's going to ask you to do that today. Okay, and so I decided that this one was a maximum because on the previous part, on part A, we saw that because A was negative, it opens downward. Because it was down, I was going to have a max. I found the max by plugging in. Okay, so if I was going to ask you to state the domain and range of that function. Okay, so things that we know. First off, I know, actually let's come back to that. So first things that I want to talk about, are there any values on the graph in which x is undefined, which means I'm not allowed to plug it in? And the answer is no. So that means my domain is going to be all real numbers. So because of that lovely all real numbers, you would tell me my domain is all real numbers. That means I can plug in any x. That is something that should happen for all of our domains for our quadratic functions. So same thing happened with our lines. With all of my lines, my domain was all real numbers, and my range was all real numbers. But when we got into our absolute value, which were the V shape, my range didn't work the same way because it couldn't be all real numbers because not everything happened. I didn't get all those y values. The same thing is going to happen here. So to determine my range, I'm going to have to decide, do I have a maximum or minimum for this function? Well, this is the same function we had earlier, so for my range, I already know I have a maximum. Okay? And so since I have a maximum, what is the y value? Okay, and so in this case, that y value was -1. We already calculated that on the last slide. Okay, so because it was -1, the range can be all numbers. Okay, since -1 is a maximum, it'll be all numbers less than -1. But let's be honest, usually we don't want to take the time to try out all of this stuff because it takes up a lot of space. So remember, we can use shorthand math notation, which we're going to do. And so because of that, we're going to write the range as y. Remember, this means, this means y such that the y values are less than or equal to -1. Okay, and so this is the notation we want to use for range, and then the domain, as I wrote up earlier, we wrote it as the D for domain is all real numbers. Okay, so make sure you're being careful when you're notating. You do have to identify max or min. So if it was a minimum, my inequality would have been facing the other way because I'd want the numbers bigger than that minimum value. So that's why finding out and identifying max or min first is really, really important to finding the domain and range. So let's go determine for this one if it has a max or min value, so then we can go and evaluate the other parts of it too. So go do that right quick. A, B, or C, choose max, min, or neither. So you should have gotten a, it's taking a second to catch up to the computer, should have gotten a minimum, okay? So with that minimum, let's use that and use it on the next part, okay? So let's state what the actual max or min value is. Do you remember how to go do that? So go ahead and take a moment and decide which one it needs to be. It should be C, okay? So there we have it. So one more thing we need to talk about is how do we find the y-intercept? Because we are going to start finding y-intercepts. We have already done this before with lines, but it looks a tad bit different with our polynomials. So what we will do, let's go ahead and get a function so we can get an example. So my function is negative x squared plus 5x minus 2. I want to find the y-intercept. So before we actually go and calculate it out, let's talk about what is a y-intercept. So let's see who remembers. So I'm going to pause and you tell me what a y-intercept is. So for those of you who got it correct, the y-intercept is where the function or equation crosses the y-axis, not the x-axis. So as a reminder, we cross the y-axis when x is 0, because that's, no matter where we are on that y-axis, the x value is 0 there. So because of that, I can calculate it by plugging 0 in to my equation. So it would give me negative 0 squared plus 5 times 0 minus 2. So I'd have negative times 0, because 0 squared is 0, plus 0 minus 2. Negative 0 is just 0, so that's nothing, so I am left with negative 2. So in this case, my y-intercept is the value of negative 2. If you want it in point form, it is 0, negative 2. So that's going to be the end of our lesson today. So make sure you take the time to go and do your homework and ask me if you have any questions. Your homework does include graphing, a couple of problems. So let me know if you get stuck or confused or need help with any of them. Hope you have a great day. Bye.